It hits you instantly. Your chest tightens, the room closes in, and your body braces for an impact that isn't actually happening. Within seconds, your heart rate spikes to saturate your limbs with blood, your breathing becomes shallow to maximize oxygen, and your peripheral vision goes dark. Our first instinct is to try and think our way out of it, to tell ourselves there is no danger. But logic fails here, because this is a physiological event, not an intellectual one. The process begins here, in the amygdala, the brain's primitive threat detection center. When the amygdala detects a threat, it sends signals that physically overpower the prefrontal cortex. The part of your brain that handles rational thought is rendered effectively silent. You cannot reason with a brain that has temporarily disabled its capacity for reason. To stop this hijack, you must use a physical intervention. A panic attack is an ancient biological alarm, doing exactly what it evolved to do. To turn it off, you have to engage the body's own regulatory pathways. The most accessible way to influence this internal state is through the mechanical act of breathing. The vagus nerve structurally connects the lungs and heart. Making your exhale longer than your inhale creates a specific diaphragm rhythm. The vagus nerve detects this, releasing neurotransmitters commanding the heart's pacemaker cells to slow down. This leads to a cascade of physical changes. Blood pressure drops, the adrenal glands stop releasing cortisol, and oxygen levels begin to stabilize. By controlling the breath in this specific ratio, you aren't just trying to relax. You use a biological pathway to physically demand the panic stop. Once the heart rate begins to descend, the next phase focuses on changing the sensory data the brain is receiving. The intense tunnel vision experienced during a spike is designed to help lock on to a predator, confirming to the brain that danger is still present. If you intentionally widen your gaze and take in your peripheral vision, you provide the brain with visual evidence that the environment is clear, which helps quiet the threat response. For cases where breathing and visual changes aren't enough, an extreme sensory change can be used, exposing the face to a sudden temperature drop. This initiates the mammalian dive reflex. The body immediately reroutes blood flow toward vital organs to conserve oxygen. This forces the parasympathetic nervous system to take over, flooding the body with calming signals that override fight-or-flight pathways. By radically changing your visual field or your physical temperature, you force the nervous system to shift its focus away from the perceived threat. Once the biological signals are regulated, the body begins to return to a calm baseline. This process shows that anxiety is not a mysterious emotional failing, but a series of predictable mechanical functions. You are not a victim of your nervous system. Instead, you can learn to act as its operator. To be effective, these physical steps must be practiced while you are already in a state of calm. Practicing while calm makes the neural pathways associated with the reset protocol grow stronger. It ensures that when a crisis does occur, the connection is already primed. With practice, the transition from a state of panic to a state of regulation becomes more fluid, reducing the time spent in a high-stress loop. Understanding your own physiology transforms a panic response from a catastrophic event into a manageable physical sequence.